In the previous example, I showed how to compute mean and standard deviation for a discrete random variable using Excel. Now I'm going to show using StatCrunch. Now, I want you to notice here when they're talking about a lottery and how much the prizes are over here, and then the probabilities on this side, they're asking for the expected cash prize. So let's see what else. Furthermore, we have to take into account if a ticket costs $1, what is the expected profit from one ticket? Okay, so expected value, although the explanation of it is slightly different, it winds up being the same as the mean. Again, you might get a definition of mean and of expected value that sounds slightly different, but in the end, they are the same. And that is because expected value, we're talking about what we expect to happen in the long run. Okay, so opening this up in StatCrunch. So notice that the probabilities here, some of them are so small that it's expressing it in their version of scientific notation. Anyway, if we go to stat and calculators, we're going to have to go to custom, I believe it is. Let me enlarge this tab. Try it again. There we go. There's custom right there. And our values of the cash prize are in this first column. The weights are the probabilities. When we compute, it's going to give us a graph, and without all the work compared to what I showed in the previous video, it's going to give us the mean and standard deviation. So here we go. Now, keep in mind that we're talking about the profit having spent $1. So just the winnings, when we round to the nearest cent, that would round to 0.28, 28 cents. And subtract $1 from that because you spent that. That's going to be a loss of 72 cents. So negative 0.72. Let's check that out and see if we get agreement here. Okay. Wonder what happens if we put in the 0.28. That is strange. I thought they were going to have us take away the $1 that is spent. So it does not mean that we would win 28 cents every time. And it does not mean that on average we would profit. Okay, so they only asked for the expected cash prize back here. They didn't ask for the expected profit just yet. Okay, so choice A, on average. So if we keep doing this over and over and average it out, we'd have about 28 cents in our winnings per ticket. think here's where we need the negative 0.72. Yes, okay. And to the nearest million, how much should the grand prize be so that you can expect a profit? So to solve this, I had this bright idea, which gets pretty close. I'm not quite sure what's going on with the answer that winds up being in there, but let's check something here. Okay. This is a little heavy duty on the symbolics, but that's all right. I'm going to try to break it down, explain what's happening here. Here is our formula for the mean of the random variable, which is the same as the expected value. And if I break off, how much should the grand prize be? What we want to solve for, assuming that all the other prizes are worth the same amount and all probabilities stay the same, then if I break off that first product from all the other products that we're adding up for all the other prizes, then I could do a little bit of algebra. I was assuming, since things are being rounded to the nearest cent, that we would want a profit of 1 cent. And so the winnings would have to be, since the ticket costs $1.01. So change that. Okay, well, I could isolate what we're solving for, the value of the grand prize times its probability by subtracting the sum of all those other products from 1.01. And then divide by the probability of the grand prize, assuming again that stayed the same despite the change in how much the grand prize is. So divide both sides by that probability. And I set that up in Excel. Show you what that looked like. Let's see, where's it at? There we go. Okay, so came up with all the other products besides that grand prize of 18 million, came up with all the other products over here, added them up, and then took 1.01 minus that sum and divided by the probability of the grand prize. And they wanted the answer to the nearest million, so I rounded down to 142 million, and it did not accept that answer. Let me show you what they did give. They gave an answer of 141 million. So that must have meant that my idea was something in the ballpark. And I'm not quite sure what happened, but I did try a lower amount than 1.01, but something bigger than 1. And for example, if I switch that to 1.001, so a profit of 1/10 of a cent. Now, if I round that to the nearest million, I do get 141 million. So, okay. Now that's a lot higher than 18 million. So I would not expect that they wanted guess and check there. So if you try something out like what I showed and you're off, well, try lowering how much that profit would be. So it would have to be something bigger than the cost of the ticket though. All right, does the size of the grand prize affect your chance of winning? And to solve part B, I made that assumption that it was the property of the lottery, not the payouts. I'm not sure if that's what they want here. So let's see. Okay, good.